Hi everyone. Today we're going to finish up with lesson 8.1, solving trig equations using inverses. Today we're going to find all of the possible answers. And by all, usually I mean two answers. Generally, if we're looking at where sine is positive, there's two quadrants, or where cosine is negative, there's two quadrants, or where tangent is negative, there's two quadrants. So generally there's two answers. So today we're going to solve trig equations and find all of the angles. We're going to use some algebra, we're going to use some trigonometry, mainly inverse trigonometry. So a question might ask, what are all of the angles that have a cosine value of 0.57? So when I do this problem, I always think about how many possible answers are there? Where could the cosine be positive? I remember that the cosine is the x value on the unit circle, so the cosine value is positive in quadrants 1 and 4. So I'm going to have two angles. One is a quadrant 1 angle and one's a quadrant 4 angle. So step 1, I want to find the inverse cosine of 0.57 to find an angle. Okay, my calculator will always help us give us one angle. Okay, and depending on whether we're in degree mode or radian mode is which, okay, the problem will say either find the angle in degrees or find the angle in radians. Step 2, we're going to evaluate it. And I showed you both answers. The inverse cosine of 0.57, if you're in degree mode, should give you 55.25 degrees. Or if you're in radian mode, a little less than 1 radian, 0.96. Okay, which is accurate because it's a little less than about 57, 58 degrees. Okay, when using technology to solve the trig functions, make sure you have it in degree mode or radian mode, depending on what the problem's asking. Okay, a lot of times when we do circles, I see radians, but I've also seen these problems in degree mode as well. Now, like I said before, there's not just one angle. So one of the angles is 55 degrees. We got to find out the other angle. Now, you can call this angle negative 55.25 degrees, or you can also do 360 minus 55.25 and get 304.75 degrees. Now you got to be very careful and answer the question. If the question says it wants two positive angles, don't tell me it's negative 55.25. If it says what's a first quadrant angle and a fourth quadrant angle, then we have flexibility. And same thing with radians, it's 0.96 radians up, it's negative 0.96 radians down, or if we want to find the positive, we have to do 2 pi minus 0.96. And whatever you get for that is our answer. So depending on what the question asks, we definitely need to find the first quadrant angle and the fourth quadrant angle because cosine's positive in these two spots, but it'll tell you how to format your answer. Okay, now we're not done yet because there's technically an infinite amount of angles. Okay, so we need to define all of the angles, and this is where the plus 360k or plus 2 pi k is, because this angle up here is 55 degrees, or it's 55 plus 360 degrees, or 55 plus 360 plus 360 again degrees. So the easiest way to say that is 55 plus 360k, or from radians, 0.96 plus 2 pi k. And we have to do this with both the first quadrant angle and the fourth quadrant angle. So likewise, we do it here. 55.25 plus 360k and negative 55.25 plus 360k. Like I said, we can do this with a negative angle, or we can call this 304.75. But this tells us there's an infinite amount of angles that are in the first quadrant that wind up here, 55 plus 360 and plus 360, keep it as spins. And there's also negative 55 plus 360 gets us into the fourth quadrant. So let's try it with tangent. What are all the angles that have a tangent value of negative 0.35? So if you want to try this one all on by your own, pause the video, go for it. If not, I'll walk you through the steps a little faster. So the first question I ask is, where's tangent negative? Tangent's the slope of the hypotenuse, so tangent's negative in quadrants 2 and 4. So I'm going to have two answers again. Okay, and my calculator gives me the angle in quadrant 4. So if I'm in degrees or radians, and right now I'll just stick with degrees and talk about this one, but radians, same idea. So my reference angle is 19.29 degrees. So I need to do this angle up in the second quadrant, so I can do 180 minus 19.29 and get 160.71. So I have negative 19.29 degrees and I have 160.71 degrees. So my two answers, okay, and this one's a little weirder because I actually only need to say one answer. Okay, and the trick here is thinking with tangent, it repeats every 180 degrees. So I can say it's negative 19.29 degrees plus 180k. Tangent's a special one that I only have to do half a spin to get to the next answer. So negative 19.29 plus 180k, or I would have probably written it as the positive, so I like 160.71 plus 180k, where k is an integer. K means we can go forward a full spin, a full half a spin, or backwards half a spin, or backwards two half spins. So plus 180k means make a half rotation and you're at the next possible answer. Now you get to try it. All the angles that have a sine value of 0.95. Pause the video, try it out, see which step do you get to before you have a question. Then think about what is a good next step. Okay, so sine is positive in quadrants 1 and 2. Okay, so this answer, I don't like this answer. That answer is wrong. So 71.8 degrees is the first quadrant angle. And then the second quadrant angle is 180 minus 71.8 to get into the second quadrant, which should be 108.2 degrees plus 360k. So we can find the first quadrant angle and give it a full spin. So I could add 360 or 720 or to the first quadrant angle, 71.8, or I can add it 360 to 108.2 and still get to the same spot. So we really need to know where is sine positive. Those are the two quadrants. You gotta get an angle in each and then add 360k to find it. Now, try for cosine. And once again, we can be in radians or degrees. I'm pretty sure I'm going to give you the answer in degrees. Pause the video, test it out. Okay, so where is cosine positive? It's positive in the first and the fourth quadrants. I need two angles. So with cosine is nice because I could have the positive and the negative. Or once again, I could do 360 minus 57.3 if you wanted 302.7 degrees. You could have had 302.7. But in mathematics, we're going to try to take the path of least resistance. So we're going to have the positive to get into the first quadrant and the negative to get into the fourth quadrant. Once again, plus 360 to get all of the angles that are coterminal at 57.3 and coterminal at negative 57.3. So if it asks you what's the angle, there's an infinite amount of choices. Now the question also might say, solve and find all the values between 0 and 2 pi. So it just wants a limited amount of answers. To write this equation down, we're going to talk about how to solve it. You may already have some thoughts. Okay, we got to solve for theta. So here's a list, and we're going to talk about each step. Okay, and you don't need to write the rules on the side of what you're doing, but it may help to think about why do I do something. So my goal has always been to get the variable on one side. So I'm going to try to subtract 3 sine theta on both sides to get 3 sine theta equals 2. Now I see if I'm trying to find the angle, I want to use inverse trigonometry, but I can't do that with this 3 over here. And since this 3 is connected through multiplication, I divide. If there's other parts that I need to move, I can use addition and subtraction and multiplication and division, depending on what process I'm trying to undo. So I have the sine of the angle equals 2/3. And I can take the inverse, like we've done in the previous problems. Okay, I like how the book says use technology. Use your calculator, practice with your calculator. And since it says between 0 and 2 pi, I'm guessing it wants radians. Okay, if it says between 0 and 360, I'm in degree mode. 0 and 2 pi tells me go into radian mode. So I'm not going to even pay attention to this 41.81 degrees. Now I know that's one answer. I also know that there should be a second answer because sine is also positive in the second quadrant. So I need to find the second quadrant angle. Therefore, I take pi and I subtract my reference angle of 0.73 radians, and I get about 2.41 radians. So my two answers are 0.73 and 2.41 radians. Those are the only two angles that are between 0 and 2 pi. Now I can find other angles by adding 2 pi to each one of those, but those would be above what the question's asking me to find. The question's only telling me to find the two angles within one rotation of the circle. So if you can get to sine of theta or cosine of theta or tangent of theta, then we can use the inverse. And now you try it. Okay, I want you to find the values of theta that make that equation true. My hint is that you're eventually going to use inverse cosine, but you got to do a few things first. So try it out, pause the video, test it, and we'll see how you did. Okay, so I need cosine is going to be positive. So it's the first quadrant and the fourth quadrant. So the way I got 5.64 is I took 2 pi minus 0.64 to get 5.64. Once again, it says between 0 and 2 pi. I don't really know why I'd ever give the answer in degrees. Technically, it's right, but if it tells me be in radian mode, I'm going to be in radian mode. So to quickly go through this question, I'd subtract 0.25 cosine theta from both sides. You get 1 equals 1.25 cosine theta. I divide both sides by 1.25, and then I take the inverse of this fraction. And I'm not going to divide the fraction and round until the end. I just take the inverse cosine. My calculator is strong enough where I can do inverse cosine of this, and it should get me 0.64. Okay, it's a positive. So once again, I know it's in the first quadrant and the fourth quadrant because cosine's positive there. Now you get another attempt. Okay, now I just want to angle between 0 and pi. So I'll give you a hint, there's only one answer here because tangent is positive in the first quadrant and negative in the second quadrant. So it's either a first quadrant angle or a second quadrant angle between 0 and pi. Pause the video, see if you can do it. Let's see how you did. Okay, one angle, 1.11 radians, 63.43 degrees in quadrant 1. Okay, I subtract tangent of theta from both sides and add 4. So I wind up with 2 tangent theta equals 4. I divide and get tangent theta equals 2. And then take the inverse tangent of 2. I see this is positive. so that I know I got to be in the first quadrant, and it gives me 1.11 radians. So I can use inverse tangent and inverse sine, inverse cosine, inverse trigonometry to find missing angles if I'm given ratios. I can use it to solve. Okay, theta is a missing angle. I need to solve, so I need to use inverse trig. Okay, inverse trig, I'm given the ratio, so the ratio is between -1 and 1, and the output's the angle. Now we just need to remember our calculator for sine is either going to give us a first quadrant or a fourth quadrant angle, so somewhere between -2 pi and, or negative pi over 2 and pi over 2, so somewhere on the right side of the unit circle. Inverse cosine is going to give us somewhere in quadrants 1 or 2 between 0 and pi. And tangent is like sine, where it gives us between negative pi over 2 and pi over 2. So if it gives us one angle, we always have to understand that there's another angle somewhere on the unit circle between 0 and 2 pi that has the same ratio. And that if it asks for all the angles for sine and cosine, we have to add 2 pi k for an infinite amount of spins to have a correct equation.